This is question 15 from the 5.2 MyLab Math homework. And we're told an automobile company is ready to introduce a new line of cars through a national sales campaign. After test marketing the line in a carefully selected city, the marketing research department estimates that the sales in millions of dollars will increase at the monthly rate given by this function for T months after the campaign has started. Okay, so we're being given marginal sales here, the rate of change of sales. There's a domain restriction. This function is only valid 0 to 30 months since the campaign has started. It's really important to understand what your input and output of the function are before you try to use it. So we're inputting T, which is the number of months after the campaign has started. We're outputting sales in millions of dollars, so keep all that in mind. But then we're being asked to find the total sales S of T months after the beginning of the national sales campaign if we assume no sales at the beginning of the campaign. So the beginning of campaign would be time 0, right, at month 0. And they're assuming that if you plug 0 months into the sales function, which we'll find by doing the antiderivative, we should get $0 out. So plugging in 0 months should get us $0 in sales. So we'll use that information to find a particular sales function, but let's start by finding that generic sales function. So we know that if we're given S prime of T and we take the integral of it, we're going to end up with a generic sales function with some constant being added. Okay, so let's go ahead and find that. So I'm just going to set up my integral. Let's see, I'm taking the integral of 19 minus 17 e to the negative 0.1 t. I'm putting that in parentheses because all of that is my integrand. And then I'll put like my little bookend here. Okay, now there's technically 2 terms in my integrand. There's 19, that's just a constant. So that would follow the reverse power rule. And then there's a term that has an e in it. So that would follow my reverse e to the x rule. So if it helps, you can split this integral up into 2 different integrals, especially since the terms are going to follow 2 different rules. So I need to find the integral of 19 dt minus the integral of 17e to the negative 0.1 t dt. Okay. So let's start by finding the integral of this first term. Now it's just a constant 19, but if it helps, you can go ahead and rewrite that with a t in it, right? Wouldn't that just be t to the 0 power? And that will help you see that reverse power rule. Also, you can pull out that 19 constant if you would like to. Just remember it's there if you pull it out. Okay, so when you take the integral, you're going to have that 19, and then you'll just increase your 0 exponent by 1 and divide it off. And I'm just going to write that plus c at the end because the constant will just be added to another constant from the next term to create a different constant. Okay, so let's go ahead and finish up this power rule here. Let's clean that up. So that's going to be 19t to the first over 1, which is just 19t. Okay, so now let's find the integral of my second term. Now this is following my e to the x rule, so I'm going to write out my reverse e to the x rule. This is the one we like, right? Because if your integrand is e to the x, when you reverse it, the original function was also e to the x. But here's the problem. My exponent needs to be a plain variable to follow this template. And right now my exponent is not a plain variable. So we will use u substitution. So I'm going to let u be my exponent. So let me write that over here to the side. And then I can pull that 17 out if I want. That'll help me match my template a little bit. Right, pulling that 17 out. But I need to convert this dt to something that has du in it. So I'm going to come back over here where I set up this rule. I'm claiming that u can now replace the negative 0.1t. Anytime I see a negative 0.1t, I can put a u. So if I take the derivative of u with respect to t in this case, because that's the other variable we're using, that derivative is just going to be a negative 0.1. And then I'll multiply the dt on both sides. So then we're going to get that du can cash in for a negative 0.1 dt. Okay, there's a little delay here with my app. Okay, and then I see that I have the dt, but I don't have this negative 0.1. I had a 17, but I'm going to pull that out. So we're going to use the idea of just using what you have. So I'm going to divide off the negative 0.1 on both sides. And that'll leave me a plain old dt there on the right, which is what I wanted. And then to simplify this a little bit, I'm going to see that I have an understood 1 in front of the du, and I'm going to go ahead and divide off 1 divided by that negative decimal to kind of clean that up. Okay, and that gave me a negative 10. So now when I see a dt, I can replace that dt. I can replace this. I can swap it out for a negative 10 du. So over here where I had this dt, I'm going to replace that with a negative 10 du. Okay, so what does that look like? Let's go ahead and rewrite all this. So I'm going to go ahead and pull out that 17. Then I'm going to have the integral of e to the u because I replaced that exponent with a letter u. And then that dt is going to cash in for a negative 10 du there. Okay, again, I have a constant in there, a negative 10, so I can pull that out in front of my integrand, and it's just going to multiply with what's already there. So when I do that, I'm going to end up with a negative 170 e to the u du. Oh, this pesky plus c is floating around over there. I'm going to circle it really big so I can remember to put that in my answer. In fact, maybe I'll just write it down here somewhere, plus c. Don't forget that plus c in my final answer. Okay, so let's go ahead and take this reverse e to the x rule here. Let's follow our rule here, because now it's just an e to the u. That's what we wanted. So when I reverse that, I'm just going to get 170 e to the u plus c, but I already tacked on that plus c there. In fact, let me move that plus c a little bit closer. I'm so afraid that I'm going to forget it. I'm just going to move that a little closer. And now I just need to unsubstitute that u in my exponent. So this u is going to get replaced with negative 0.1 t. Okay, so, and remember, we were reversing my marginal sales. So the thing we just created by following these reverse rules, by working backwards, the thing we just created was the sales function. So this is s of t. Okay, but remember, this is generic. This is generic s of t, just assuming, any input or output are going in. But we need to make this a specific function. We need to find this value of c here using that extra information they gave me about no sales when the campaign began. So I'm going to input a 0 and output a 0 and see what my constant would have to be to make that happen. Okay, so I went ahead and I took that generic function and I inputted 0 everywhere I saw a t. And then I know I need to output a 0. So that's what I'm doing here. And we'll just figure out what constant will make that happen. So 19 times 0 is 0. Minus, I have 170 e to the 0 power. E to the 0 power there. Okay, but any non-zero base to the 0 power is just 1. So I really have 170 times 1. So I really just have 170 there. And then when I add c, I need the output to come out to be $0. So c has to be a positive 170, right? Yeah, if negative 170 plus the constant is going to give me a 0 output, that constant has to be positive 170, because negative 170 and positive 170 would add to 0. So now I know that specific value of c. So I'll just go ahead and replace that down here in this function. And now we have a particular sales function for this particular situation. And now for any input they give me, for any number of months since the campaigns began, I can output some dollar amount after that those number of months have passed. Okay, so there we go. We have a particular total sales function. Now remember, when you have that output though, it's going to be in millions of dollars, I didn't have to think about that very much when I was outputting $0 because $0 million is still $0. But in future parts of this question, for example, if they wanted me to calculate the total sales after 5 months, I would input a 5. I would follow this rule, and whatever number is outputted is actually in millions of dollars. So again, anytime you have a function, always be very clear on what is being inputted into the function and what the output is telling us, what's being calculated, and be really careful with units.